Leo, can you see? You got YouTube? Have you got YouTube there?
Yes.
YouTube's up?
Twitch is off. YouTube has, there's delay. YouTube's on. Twitch is on.
Cool.
And what about Microsoft Teams? Oh, sorry, Stream.
So we good to go?
I didn't have the link to Microsoft Stream.
The other guys just found it.
Oh.
Can you not find it? Just go to... Sorry, folks. Can you... Is this miking okay? Can you hear at the back? Yeah? So have you got the streams thing there, Leo? It's up.
It's still loading.
The streams is.
Yeah, Stream is still loading. The other two platforms are working properly.
I can see streams live now.
Can you just send it to me?
Send what?
This link.
Mm-hmm.
Yep. I can figure out where.
All good? Okay, folks, welcome. Is that loud enough for you all? Yeah, I can't hear it very well. That's all right. Just 1 second. Okay. All right, welcome, folks. Welcome to COMP1110. I'm absolutely delighted to be here and be lecturing for you. And it's fantastic to see you all in person, or at least half the class in person. And for those of you who are watching on the live stream, what we're doing in this class is something a little bit crazy. We're trying to do the hybrid lecture thing. Last time I ran this, of course, I did it just from my little office at home. And that was hard enough. But now we're trying to do both because it's a lot more fun to be in person. But it's also a little bit more fun to set up. And the previous lecture I ran a little bit over. So sorry about the slightly late start. Just checking with Leo. Down the front here we've got Leo. Leo is one of your amazing tutors in the course, and what he's doing is, he's right here in the front row. What Leo is doing for us all is he's watching the stream where people are asking questions on Teams, and he's going to voice their questions out loud for us, okay? So the people who are watching on streams can have their questions voiced out loud, so they'll be kind of participating that way. And he'll be answering questions as we go along. So this is Leo down the front here, and I'm Steve Blackburn. I'm your lecturer for this semester, and I've been teaching this class for 10 years. This is my 10th year, and this will be my last. It's so sad, this will be my last. I'm going on sabbatical at the end of this, and then when I come back, I might be teaching a completely new intro class in a year or two. But it's wonderful to have you all here. It's fantastic to be in person. I'm just so glad to see you all. Hopefully, look, frankly, I think there's a fair chance we won't be in person the whole semester. The way things are in Sydney at the moment, I think there's a fair chance ACT will go into lockdown. So when you do your labs and when you do the lectures, please make sure you've got your home environment all set up and ready to go in case we have a situation where we have to go back to lockdown, okay? So just want you to all be aware of that. It's absolutely wonderful to see these, see your faces here. I've been longing for this. You wouldn't believe how hard it was last semester when I taught this class, teaching to a blank screen. It's really hard, and it's really great to have you all here so I can see you all in person. So thank you for that, and just make sure that you're all ready to go remote if you need to. Righty. What's going on here? Why is PowerPoint not working? There we are. It's working now. All right. Now, anyone know what that is? It's actually very significant. It is one of the earliest paintings in the ACT. Okay, that's up in Namadgi, not very far away. And this painting is a painting that's, I think they think the painting itself is about 3,000 years old. But the people who painted it have been living there for 20,000 or so years probably. Okay, so it's an ancient painting. It's not very far from here. In fact, my son was camping out there on Saturday night, just stone's throw away from this. So it's right in your backyard virtually. Why am I putting this here in a COMP1110 class? 2 reasons. The first one is I want to acknowledge the people whose lands we're on, right? There's a big fancy lecture theatre and all this technology around us. But the thing is, people have been here for millennia in this place, okay? Millennia. And this place here is actually named Cambry. That name is given to us by the indigenous people, the Ngunnawal Ngambri people who live here. So I want to acknowledge the people who've lived here all those years, whose land we've kind of taken here and who we've kind of subsumed here, because they've been here a long time. And I want to acknowledge their elders and their future leaders, okay? So I take that seriously. There's another reason why I'm putting this up here, and that is, this is a technology class, as most of you will have realized, but technology cannot exist in isolation, okay? Technology is a human endeavor. I'm going to emphasize that throughout this class. And this is part of our cultural context. Whether you were born in Canberra or Beijing or Delhi, wherever you were born, this is part of our human culture. And if you happen to be from Canberra, this is very much part of your culture, okay? So this is the context in which we build technology. Don't forget it, okay? That's why that's there. What? Oh, I see, my keyboard's this keyboard's got the arrow in the, not where I thought it was. Okay, who am I and why are we here? As I said, my name's Steve Blackburn. I'm a professor in computer science. I've been around for a while. I did my PhD here, believe it or not. And I do research in language implementation. So we're going to be studying some stuff about Java in this course. I build the innards of languages like that. That's what my research lab does. We work with people who build JVMs. We work with the producers of these things. In particular, I work on memory management, which is one of the key technologies for making languages fast and safe. Now, I want all of you here to be excited to be here. I want you to lift your sights high and think about what you can do. In the 10 years that I've been teaching this class, some amazing people have gone through the class doing all kinds of stuff. One of our most amazing junior academics in our school is someone who took this class and is doing incredible stuff with Indigenous culture and a whole lot of other things with computer science, has a PhD in that area and is doing incredible work there. Another person I can think of who took this class, he's now a senior person. In fact, he's responsible for the Rust programming language inside of Microsoft. Another person I can think of, I'll give you another anecdote. This is a pretty funny one. So there was one student who took this class, 2 students who took this class, and a year or so after they took the class, me and a couple of other academics had an idea for a startup, right? And we got these 2 people were pretty good. We got them involved and said, let's build this thing. And we worked together for a few years on this startup, which was this amazing thing. Anyway, it's amazing startup. It went nowhere, right? Okay, so it went nowhere. After 3 years, it went nowhere. But those guys, those 2 students who both did this class, they learned a lot, right? Now, a few months ago, I found out that one of those 2 guys went on and started another startup after that. That startup just sold for $1 billion. Okay, that's one of the stories that came out of this very classroom. Well, not this classroom, this is a brand new room, but came out of this class, out of COMP1110. And there are a lot more like it, all different paths, right? People chasing money, people chasing all kinds of dreams, different dreams. I'm not the sort of person who chases money, but there's all kinds of things. So no matter what your enthusiasm is, I want you to feel like you have a great opportunity here. You have a great opportunity to be in this university. You've got a great opportunity to be doing this class. So grab it, okay? Grab your opportunity. Now, before we go much further, I want to talk a little bit about the mechanics of this class. I'm now going to go to a split screen here for the people on the stream. The mechanics of this class. And we'll talk quickly about the web page. I'm at risk of talking too long here. Here's a web page. And what I want to do is highlight a few really important things. First of all, see this thing at the top here. You should always be looking at that. That tells you what's happening this week. It tells you all of the lecture modules we're doing, which labs are on, and what's on Monday, what's on Friday, and all sorts of stuff here, okay? In particular, I want to show you that when you click on one of these, you get all of the material about this lecture module. That looks pretty sparse there. That's because, but shortly there'll be a video here. After this lecture, there'll be a video here. And if you go to the Java one, you get all the different Java modules. There's a ton load of material here, including a PDF, which is not showing. Yes, it is. It's just a bit slow. And here you get Java visualizers, which are amazing. We're going to see that later. And you get references and all sorts of stuff. Okay, so there's a lot of information, and all that sort of information I just showed you goes on and on and on for every module in the course. So there's a lot of information there, which means that you can dive in and navigate this course the way you prefer to learn. So different people have different styles, different ways of learning. This allows you to take it your own way. Okay, if you love reading articles and so forth, there's stuff in here to do that. If you love seeing live demonstrations, there's stuff here to do that. And if you just like reading the slides, they're here as well. And the video will be here if you want to rewatch that. Okay, so please take a few minutes to navigate this web page, which is really, really important to this course. Now, before we go any further, I want to find out where people are from. If you're on the live stream, please say a thing about where you're from. Anyone in this room who's not from Canberra, just give us a shout where you're from. Yeah, where are you from? Magnetic Island. Oh, that's so awesome. Magnetic Island is one of my favorite places. That's near Townsville, folks. Melbourne, fantastic. Adelaide.
Yeah, I'm from Adelaide as well.
Where are you from?
Adelaide.
Adelaide, yep. Great. Anyone not from Australia here? COVID's really ruined. Oh no, fantastic. Where are you from?
Canada.
Canada. Fantastic. The Maple Leafs. All right. And at the back there? Where are you from? Nope. All right. So it's great. We do have people who've managed to get through the COVID Iron Curtain and come all the way to Canberra. So welcome everyone. And for those of you who are online who can't come here, you're extremely welcome. And we're doing everything we can to make this class engaging for you just as much as it is for the people in the room. And our labs, we have labs which are online and we have labs that are in person. And if you can do an in-person lab, great. If you're stuck and you can't do an in-person lab, do an online lab. We've got fantastic tutors who are really experienced at doing this. All right, let me quickly go through a few things here. One of the most important things I want to emphasize here, if you go here, it tells you all the things that are supposed to happen this week, right? Make sure you've read this. Really have to make sure you've read this and you're doing the things you need to do. One of the things I need to emphasize is that this course has a fast start. It has a fast start. Why does it have a fast start? Because I want to crush you all at the start? No. That's not why it has a fast start. It has a fast start because, oh, incidentally, what do you think this course is about? Is it about Java? No, it is absolutely not about Java. Java is merely a tool. Merely a tool. It's about structured programming, folks. It's about structured programming. We want to get that tool under our belt before we can get on to doing structured programming. This is about interesting computer science. Learning a language is not in itself particularly interesting. Using the language is what's interesting, okay? So this course is not about Java. It's about other things. And we have a fast start because one of the key parts of this course, remember I said before that one of the key things about computing and what we do here is our technology gets put into context. It's also a deeply social technology, okay? Some people think of computing as being a very solitary thing. It absolutely is not solitary. Let me tell you. Just before COVID, I spent 3 months in Munich working with the V8 team. The V8 team, they're the team that build the V8 engine inside of the Chrome browser. Okay, fantastic team of people. Really small team. They ship a product to over 1 billion users. Okay, amazing, amazing group. They sit in one room. Most of them sit in one room, and the dynamic between them is incredible. That's how they get a product which is incredibly reliable and ships to 1 billion people. It's about the dynamic between the people. It's about working together as a team. And one of the key learning outcomes of this course is teamwork. Okay, you're going to build a project as a team. Okay, it's a social outcome rather than a straightforwardly technical one. All right, and so we want to get yourselves up to speed quickly so you can get on and do the fun stuff, which is building interesting software. Okay, and you can't do that until you've got through a bunch of relatively boring stuff. Okay, so we have to whip through the first few weeks. And what happens if you fall behind in those first few weeks? The answer is you just need to keep going through it. There's loads and loads of resources to help you. And you'll see here, I'm going to tell you more about the resources soon. don't panic, okay? If you feel like you're drinking from a fire hydrant, don't panic. That's how a lot of the students in the class will feel just for those first few weeks. The pace eases up after that once we've got these necessary things under our belts, okay? So if you're feeling overwhelmed by the end of this lecture, don't panic, things ease up, and there's tons of resources to help you out. All right, let me keep going here. Other crucial things, there's a schedule here. You need to look at the schedule and read that schedule. There's you've got the learning objectives here. One of the key ones, as I said, is a social one, learning to work as a team. Deadlines. Now, you guys are probably going to think I'm a really mean person. We have deadlines here. These deadlines are non-negotiable, okay? We put the deadline in there and say, this thing has to be delivered then. If you don't deliver then, you don't get it marked, okay? That sounds pretty harsh, but that's how things work in the real world. And of course, I'm not as harsh as all that. It's just you won't get that thing marked. We'll assess you in a different way, okay? So if you get ill or whatever, there's really good, robust processes for helping people who are sick or have an accident or whatever. So don't worry about that. If you simply miss a deadline because you weren't organized, then that's a problem. However, many of our early assessments are what we call redeemable. What that means is that if you get 0 for this thing because you missed the deadline, what you'll end up getting is your exam mark for that assessment, okay? So for a whole bunch of the assessments in this course, they're redeemable, which means that for any given assessment, which is marked redeemable, not all of them are redeemable, for any of the redeemable assessments, we look at your exam mark and we look at the assessment you got, and you get whichever is higher, okay? So if you're totally nailed and you don't know what to do, don't panic. If you get 0 for that, you're going to wind up with your exam mark for that thing instead, okay? So this harsh deadline policy is there for a reason. One of the reasons why it's there is because as soon as those assignments are in, as soon as those deliverables are in, we share it amongst each other and we can talk about how we solve the problem. Obviously, we can't do that if people are dribbling in answers for the next weeks, okay? So as soon as that deadline is done, I'll post something on Piazza and you'll know that you can talk about it with your friends, okay? So that's how we learn. Yep. Disconnected on streams. I didn't do anything. So yeah, Leo says we're disconnected on streams. I can see myself here actually. That's me there. So it seems to still be working. It's just a bit slow, I think. So unfortunately, we're using, if you end up watching this online, oh, here we go, event has ended. So Leo, it has died. It died just now. So Leo, can you just ask people to watch it on Twitch or YouTube? We streamed to 3 different channels. The reason why we're using Microsoft Streams, which is by far the least reliable and the most annoying of all of them, is that it can be seen in every country, right? But for those who, Leo, can you just remind everyone, if they can only watch streams because they don't have access to Twitch or YouTube, remind them that the recordings are all made available usually later on in the day, like late tonight, maybe the recordings will be up. So no one's going to miss out on this, okay? All right, that's a very important lesson, folks. The technology, even the latest technology, we've got a fantastic network connection here, incidentally. That's not the issue. It's just the underlying technology is a bit shaky. So let's keep going. We don't want to run out of time here. Deadlines, I told you about that. Now, another crazy Steve rule, no email. I don't do email, okay? So a bunch of people have been emailing me about all kinds of stuff. Don't do it. No, no, no. Why not? Why don't we do email? Because email is a really bad modality for communication in a large group. It's just a terrible way to communicate. Don't do it. Instead, we have Piazza, we have a forum. You communicate in the forum. And if you have a question like, is this assignment really due on that date? You ask it to everyone, and then people can correct you if you're wrong, or if you're right, then the lecturer provides the answer, and everyone learns from your question. Or if you have a question about some technical thing, same thing. If you don't know how this thing works, probably there's a whole bunch of people in the class who also don't know. That's why you ask your question in a broadcast forum, not in an email just to the lecturer. I can't answer emails from 480 students. We've got 480 students in the class. I can't answer all your emails individually. Okay, so use the forum. We've got a ton of tutors who are all watching the forum, and we try to get things answered quickly, okay? The forum is supposed to be pretty good, and you should find it good, okay? So it's responsive. And of course, if you have something of a personal nature that you need to talk to someone about, you can write a private message to them on the forum. Still use the forum. Do not use email, okay? Email is not the way we communicate here. All right, we have a code of conduct. This is really important. Why do we have a code of conduct? Because, remember, this is a social endeavor. Okay, this is not a purely technical endeavor. It's a social endeavor. And it's important that you, understand that. And hang on, what have I done here? I meant to do this, yeah. It's important that you understand that, and to do that right, you need to understand how we behave, okay? We don't behave like jerks in this class, okay? If anyone does, I come down on them very, very hard and fast and quick. It doesn't happen in this class very often at all. In 10 years, I've seen it once or twice. I don't expect it from you guys. I'm sure you're all really super lovely people, and I'm looking forward to getting to know you better. But I want everyone to act the right way. And if you see someone who's stepping out of line, just point them to the code of conduct, okay? Just remind them, okay? It's really important. If you did this at a big workplace, if you behave poorly in a big workplace, you might be out of a job, right? Same here, okay? So we need to work as a team. That's how we work successfully. It's a very important part of it. Okay, now what else have we got here? I think finally, this is the part I hate doing, academic integrity. Academic integrity is an incredibly important part of every class you take, okay? And it's important not because some rule maker wants to chase you down, not at all. It's because, look around you, all those people in this room, if you violate academic integrity, you are taking down the people around you, okay? You're letting them down. That's the problem, okay? It's the people around you, okay? So please, I take it really seriously. This is an introductory class. Many people here this is the first class they'll be doing at ANU. So please understand, I take this incredibly seriously. You'll hear me say it again and again and again, okay? Do not do the wrong thing with respect to academic integrity. You need to sign a pledge. You'll do that in your lab this week. You need to understand what academic integrity rules are. There's a whole lot of stuff there. There's the ANU policy and so forth. There's one golden rule though, okay? Some people think, oh wow, it's too hard to understand. It's not hard to understand, folks. The golden rule is this: never misrepresent someone else's work as your own. It's as simple as that. Never misrepresent someone else's work as your own. If you can follow that simple rule, you're good. And guess what? This class has one of the lowest plagiarism rates in all of computer science, historically. Okay? We do really great in this class. That's because people take it seriously in this class. And I expect all of you to. So keep it up. I hope this particular class continues that. All right, back to the slides. Streams, you all should have been able to log into Streams and get yourself a lab class. The 1140 classes, some of them seem to fill up very fast. The 1110 classes seem to all be open. If you have a special situation, which means that you're not getting the class that you really need, then you send me a private message on Piazza and explain to me why you need that, and I will deal with it, okay? I always put a bit of slack into every class. Incidentally, folks, people on the stream are asking questions, or at least they're encouraged to ask questions if they would like, and Leo's going to voice them. And you all should feel free to put your hands up. This lecture, with all this stuff at the start, is a bit of a monologue. Normally, as you'll soon find out, when I give lectures, it's really dynamic, okay? Because I'm asking you, we do live coding in this class, which is why I've got all this crazy stuff here. We do live coding, so we write the programs together as a class. So I'll be asking you. So I want you to be ready to put your hand up. I'll be looking at you and saying, hey, can you answer this? Hey, what do you think we do next? Do we do an if statement or what? Well, what do we do next, okay? So I'll be watching you, and I'll be really looking forward to you. I bounce off the energy that you guys project back into to me when you engage in the class. And for those on streams, your energy is captured by Leo, who will propel it back to me, okay? So just get engaged, and you get more out of the class if you do. Piazza, please use Piazza. You should have got a Piazza invite. Microsoft Teams, we use those for the labs. They're very, very important that you get onto Microsoft Teams. You should have got an invite. If you did not get an invite, send me for Piazza. You should just wait. It takes, the ANU enrollment system takes a little while. If you can get into a lab, if you can use Streams, you should have got a Piazza invite. If you can get into a lab and you can actually enrolled and you can get into a lab but didn't get a Piazza invite, then contact me via email. That's the only exception to my rule about no email. Okay, obviously if you aren't on Piazza, you can't contact me on Piazza. Right, but Microsoft Teams, you should have got an invite already. They went out about 9 o'clock this morning. Consultation hours, one of the things we do is different people here learn in lots of different ways. We provide you not only with a tutorial, a 2-hour tutorial each week, we give you 9 hours during the week when you can go and talk to someone one-to-one. Okay, it's virtual, So it's not a face-to-face consultation, but it's virtual, and it will be a tutor. So there'll be a tutor for 9 different hours during this week available to talk one-to-one. Okay, make the most of it. These are great tutors. All of the tutors in this class took this class. They're all graduates from this class. They know the stuff backwards, and they're fantastic, highly motivated, high energy people like Leo right here. Okay, so make the most of it, enjoy it, and there's a diverse group of tutors. Oh, which reminds me, I've got to show you the tutors because they're totally awesome. They are here. You go to help here, and you go to lecturers, tutors, and peers. Oh, that's me. And then you go down here, and then here are some of your tutors. Okay, and they are fantastic people, and like I said, they all took this class in the last little while.
Sorry,
All right?
I have to interrupt again.
Yep.
I think you're not sharing the whole screen.
I'm not showing the full screen.
Sharing a portion of it.
Only showing a portion of it. It should be. Is it not all there?
It's just the top left corner of the slide.
On the slides? Really? Man, this is so thoroughly tested. Can you show me the YouTube stream? It was working a little while earlier. What's happened here? I can see it. Oh, I see.
Yeah, this is what.
Is it good now?
Sorry, 10 seconds.
Hey? Oh, I see what's going on here. It's just, okay, it's cropping a little bit. Yeah, I know what's happened here. It's to do with the video resolution. When I plugged in the HDMI cable, it changed resolutions, and it still thinks it's at a low resolution. Sigh. Okay. What I'm going to do, folks, we're just going to soldier on here. I know you've got a cropped view, which is really annoying me because what time is it? All right, let me see if I can fix this. There's a risk here that, oops, yeah. There's a risk here that when I do this, we're going to lose everything. So just bear with me for a moment, folks. And here we have this strange thing of display capture. This is really weird because now we've got an infinite regress. You all know what an infinite regress is. Desktop scene, display capture. Hey, you should see it all. I'm a little bit surprised. You should see it all. Nope. And then, oh, if we go to, oh, I know, it's probably just is it just PowerPoint that's doing this? So if I do this, can you see the whole thing? Let me just see here. I'm just going to see if this one is doing it. You're missing the bottom there. All right. Sorry, folks. There's me. Wonderful. And me. All right. So what do you think's going on here? What's that? I don't know. It does seem, it's just cropping here. Look, I'm really sorry, folks. I'll just try and keep it at the top. I think, here, I've got another solution. I've got another solution here. Just when I thought everything was working, I'm going to try and change the display resolution while we're live streaming. That's fun. All right. It's still cropping it. No, it's got it all there. Okay, that worked. I'll just try and go back again to this and see if this works. Yep, it seems to be working now. Is it? Just the very bottom of it's cropped out for some reason. Yeah, it's just cropping here. I don't know. I'll just go back to 720p for now, folks. I know it's chunky, but we'll fix this later. That seems to work fine. All right? Is that right, Leo?
Yeah.
Okay, it's just a bit goofy. All right, apologies, folks. This was tested a lot of times, but something happened when I plugged into that. All right, you need to enroll in your labs. We've got consultation hours. We've got one extra lecture the whole semester for 1140. If you're in 1140, you're doing the same lectures as everyone else except for one, and that is a special lecture by an AI expert on how to write the game that you're going to write for your assignment, which is an AI to play a game. You've got to write an AI which plays a game, and that lecture will be from an expert in AI, okay? All right, with that, let's go into this. Oh, why on earth have I got that there? Anyone know why I've got that there? Oh, interesting. Does anyone here play a musical instrument? Anyone? Really? No one? Oh, okay. A few people play a musical instrument. How many of you play a musical instrument? What instrument? Piano? Drums? That's fantastic. What else? What else have we got here? Piano, drums? Saxophone? Anything else? Flute? Awesome. Okay, so all of you people know, right? You all know that to play a musical instrument, what do you need to do? You need to practice, right? You need to practice. Practicing is absolutely essential. And unless you practice, you will not learn it. So what's fun about playing a musical instrument is making interesting music, right? What's not so fun is the practice. You have to do the practice. The same is true when you learn a new language. You don't just suddenly get to create really interesting software just out of thin air, right? Just like you don't get to play beautiful music the day you pick up a violin. Okay, it's fantasy. That's not how it works. You need to practice. So early on in this course, make sure you work through the exercises. Make yourself familiar with it. It'll feel weird and uncomfortable, just like playing a new musical instrument. It will feel strange, okay? But you will eventually get the hang of it, and when you do, then you'll be creative. Computer science is all about creativity. You're creating new software. That's what it's all about. And but for that creativity to happen, you need to have fluency, right? You don't get to be creative unless you're fluent, just like with music, okay? If you want to compose music, write new songs, you need fluency. Same with computer science, okay? So what have we got next? Access and inclusion. We take this really seriously at ANU. And this applies to at a whole lot of different levels. It applies to whether you can come to this room, whether you can hear me, whether you can see the stuff. These things matter to me a lot. If you are having problems accessing the materials, let me know on Piazza, all right? Let me know, or face-to-face if you're in the room. I'd love to talk to you, okay? And if you're having issues that are causing you to miss deadlines or whatever, absolutely 100% let me know, okay? My hard-ass thing about deadlines doesn't mean that we're not compassionate and considerate of people who've got all sorts of circumstances. So obviously, let us know. Course representatives. Course representatives, there's a blurb here about course representatives. Please consider becoming a course rep. If you go to the course webpage, you will find you'll find down here our course reps. Well, there aren't any course reps because we haven't appointed them yet. But there's a link down there. There's a link down there to a form that you can fill in if you're interested in becoming a class rep. Okay? One of the tutors this year is a class rep from last year. And in fact, I believe, Leo, you were a class rep, weren't you? Yeah, Leo was a class rep 2 years ago. Okay, class reps go on and do cool stuff. All right, so think about becoming a class rep if that's what interests you. But if you do, make sure you fill in the form and read what I said there. Okay, what else have we got here? All right, why have I got this here? What's this jet engine all about? Does that look complicated to you? Yeah, it's supposed to look complicated. But it's also, to some people, it's a thing of beauty, right? It's precision complicated, right? And it powers an A350, I think, okay? It powers a very large aeroplane, right? The point of this is that sometimes things that power, that do great stuff, like allow you to travel and whatnot, which a lot of us wish we could do right now, are complicated, and they can be intimidating. And some of the stuff we're learning in this course is like that. There's a big focus in this course on learning real-world technology, okay? Not all courses do that for good reasons, right? But in this course, we're very interested in real world technology. And what that means is that we're interested in teaching you the tools that people use in industry, and you get to use those real tools. So you're going to learn Git. People use that in the real world. It's not a very nice tool. It's ugly. It's actually kind of terrible, but it's the best tool out there, and it's what everyone uses in industry, or nearly everyone, okay? You're going to use IntelliJ, okay? Why are you using IntelliJ? Someone already asked me that question today. You're using IntelliJ, it's because that's what people in real companies and real workplaces use to develop really complex software. You can use other tools if you've got really simple software, but if you've got really, really complex software, the power of a really powerful IDE that can do all kinds of refactorings and stuff like that is really important. You're going to learn that in this class, okay? It's actually a learning outcome. And PowerPoint just, okay. Something else just happened to our, something just happened to the video there. All right, so now finally, to build a jet engine like that, you need people to cooperate and work together. It's all about teamwork, right? So this quote here is incredibly important. Look at that last line, folks. That's not a joke. That last line says solitary work is something that only happens at the most junior level. So yeah, a lot of us like working on our own. We don't like being bugged by other people. But working in a team is what it's really about, okay? And you might end up taking a job when you're first out where you do a lot of work on your own. But if you do anything really interesting, you'll almost certainly be working in a team. And if you want to do something really amazing, you'll have to work in a team, okay? So this is an incredibly important part of the class. Course goals, we're going to give you an intro to core computer science. We're going to introduce you to software engineering, and we're going to teach you software development skills. We're going to teach you a modern OO language. Oh, that jet engine was a metaphor, by the way, for Java. It's really ugly, by the way. I'm not a language fanboy. Some people are, I'm not. It's a big ugly mess, but it's what people actually use, and it's actually one of the most powerful and important programming languages in the world today, which is why we study it, okay? And it allows you to do things that many other languages don't do. I use other languages as well, but there's a very good reason for learning Java. And ugly as it might be, and some of you might have fallen in love with the beauty of a language like Haskell or whatever, I don't know what your favorite language is. Actually, that's a good question. Think for a moment about what your favorite language is. I'll come back to that in a few minutes. But whichever your favorite language is, what I'm trying to say here is Java doesn't need to be it, but Java is a language that is a very useful one to learn. All right, material. The material for this course comes from a whole bunch of sources, including the Oracle Java tutorials. If you go back to the course webpage, you go to that unit, you click on there, it walks you through the Oracle tutorials. These are actually really good tutorials, okay? So don't hesitate to use the Oracle tutorials to supplement your understanding. There's also JavaFX tutorial, and there's previous year's notes. Teaching modality. The slides, as long as the web page is working, the slides, the PDF should be available to you. If it's not, I'll fix that up. The classes, what we do is I normally talk for a brief while to introduce a new concept, and then we go and build the thing. We write code, okay? That's how classes normally work here. And they always work best when you engage. All right, so Michael Jordan said he's failed over and over again in his life, right? But the punchline is, of course, that that's why he succeeds. You succeed through failure, right? So you're going to fail at different things in this class. The thing is, I will too. You wait, well, you've already seen it, right? The video broke. This is part of how things work. We learn through failure very often. Failure is useless if you don't learn from it, though. Okay, so it's a matter of learning from that failure. And when I live code, you will see me make mistakes. And what do? You say, hey, why did you do it that way? Or shouldn't we be doing it like this? And I'll respond to you and we'll fix it, okay? Pair programming is one of the best ways to program. If you can program with 200 other programmers, even better still, okay? And that's what we're gonna do in this class. So, but failure is an integral part of it, and mistakes are an integral part of it. So don't be afraid of failure, okay? When you make a mistake on a computer, it doesn't catch on fire normally, okay? I have had one catch on fire. We had the fire brigade here once, and I was out for lunch, and the building was surrounded by fire trucks, and anyway, it turned out it was one of my computers. It had been running continuous integration tests for 5 years without stopping, and one day a capacitor blew. And true story. All right. There's online assessment. Okay, there's a lab test. The lab test is fairly early on in the semester. This is only worth 5%. It's redeemable. It's an important part of what we do in this class. You have to get through these basic things and learn how to do these basic things. There's also an individual assignment. The individual assignment will be released on Monday, 1 week from now, right before the lecture. Okay? There is content in that assignment which needs next week's lecture, which is why the assignment has not been released yet. And you get 2 weeks to do 2 weeks to do it in. Okay? You get 2 weeks to do this lecture in, and yeah. So and it comes out next Monday. You get a class engagement mark because some people like carrots rather than sticks. Those things are redeemable. There's a group assignment which is not redeemable. You need to work as a group, okay? And you get that's up to 30%. This is where you build something interesting, okay? And for the 1110 and 6710 students, you're going to build a solver for a complex puzzle. For the 1140 students, you're going to write an AI to play a game. There's a mid-semester exam, and then there's a final exam. The lab test, there's also a hurdle assessment. You have to pass the hurdle, which is called the basic competency test. If you pass the lab exam, you get a free ride on this basic competency test, okay? You don't have to do the basic competency hurdle if you got a pass in the lab test. Okay, so get a pass in the lab test, folks. Question?
For the group assignment, are they just with people in your course?
Yeah. So that, well, not in your course, not strictly. There'll be people, the 1140 students will work with 1140 students, and the 6710/1110 will work with 6710/1110. Okay, so the person in your group will be doing the same assignment as you, all right? And the assignments, let me tell you, those groups are randomly assigned. You think, man, this guy is so mean. I do so many things in this class that you probably think are mean, and one of them is that I tell you who your group mates are. But this is also, unfortunately, a bit like the real world. Very often in a group, in a work situation, someone says, all right, you're working with him, and you've got to solve this problem now, right? And you're going to have to work out how to work together. You don't know each other, but you're going to have to sit together and solve a problem together, okay? So that's part of the challenge. Social skills. How do you get on with this person you've never met before? That's a problem you're going to have to solve. And luckily, we're going to actually give you some information on how to do that in this class, okay? All right. I did that. Oops, pressing the wrong button again. This keyboard's weird. All right, plagiarism. I already talked about that. I won't talk about it further. All right, and one more quote here. Richard Feynman. You all know who Richard Feynman is? Great scientist, very interesting guy. Also got some questionable parts about him. But anyway, this I do like this quote. This quote here is telling you something. You wonder, what do I have to know for the end of your exam? You don't need to remember a whole lot of stuff. In fact, the end of your exam's open book. Of course you don't need to remember a whole lot of stuff. You need to understand things, not remember things, okay? I use Google or whatever, my search engine, to find things out all the time. I don't remember it all. What I remember is concepts. I remember ideas. I remember ways of solving problems. That's what you're expected to remember, not a whole pile of facts, okay? This course is not about learning facts. It's about learning how to build software. All right, where are we? Phew, we're already ready to move on to our first actual module of the course, and we can probably get this knocked off before the hour, which means we can have a very brief break. I normally try to have a bit of a break. We'll make it a pretty brief one this time, but it'll be after this little section here. Okay, what are we learning about in this section here? This is all about software development tools, and I mentioned earlier, this class you're going to be introduced to software development tools. What is an integrated development environment? It's a rich context for software development. There's a whole lot of them. We could have taught you any of these ones. Why do we teach you this one? We teach you IntelliJ for two reasons. One is it's publicly available. You can all download it onto your favorite operating system and run it. And it is very, very widely used. So I've got a number of friends who are serious engineers in large companies who do a lot of very interesting Java development, and a lot of people say this is the standard that most people use in many of these situations. Okay, so it's one of the most widely used ones. Eclipse is another great one. There's also Visual Studio. I use that for a bunch of other stuff. But IntelliJ is definitely one of the better Java tools, and it's very heavily used. That's why you're using it, right? Because it's available to all of you. You need to download it onto your laptop and install it, and you'll learn it in the labs. And it does a bunch of things like syntax highlighting, continuous compilation. So when you're typing, it tells you when you make mistakes, certain sorts of mistakes. It tells you straight away, which is a huge advantage. And once you get really, really complex software, it helps you navigate the really complex software, which is a massive win. You know, looking at the source code for V8, that's the thing I was working on when I was in Munich, the software is so complex. that you cannot get your head around it very easily, and it takes a long time to warm up to knowing the code base. So having a tool that allows you to drill through it and find stuff very quickly is a huge boost, a huge productivity boost. So that's why we use these sorts of tools. And it does code, all sorts of interesting code analysis. Revision control. Revision control, you're going to learn about Git. I could tell you a great story about Git. If we have some extra time in one lecture, remind me to tell you the story about the origin of Git and the guy I know who caused Git to happen in Canberra. True story. And there's also a penguin involved. True story. In fact, the person I'm talking about sometimes gave guest lectures to this very class, to COMP1110. But we'll go there another time. We use version control all the time. Software developers use this all the time. And we tend to use Git because it's a lingua franca, not because it's a great version control system. It's a very robust one. It's a very powerful one. It is a very widely used one. It's also ghastly. All right? But we're going to hide most of that from you because it's nicely integrated into the IDE we're going to be using. Don't be intimidated by it. Git is sort of almost designed to be intimidating. Okay, we're going to try and make it not so intimidating in this class and introduce you to it. There are two ways we use it. One is as a team, so when this person does some coding, they can share it with a person in their team and they can cooperate even if they're in different parts of the world. We do this all the time. Many of us work all the time with collaborators all around the world. I work with people all around the world all the time, right? And Git allows us to do that very, very easily. The other thing we do is we use it when we're working on our own. Why do we do that? Because it's a time machine. It's like time travel, all right? What happens, it emboldens you. One of the things I want you to do in this class, one of the things I hope I will get from you in this class is that you will be courageous, right? That you'll feel emboldened, right? Not timid, okay? It's really easy, particularly if you're new to technology, to feel timid and afraid of the technology. Don't be, and I really want you to take this seriously. I want to encourage you to be brave. And version control does that. Why does it do it? Because every time you do something good, you lock it in. Okay? If a little while later you make a complete mess of everything and your computer hasn't caught on fire, then you can go back to where you were, to where everything was good. All right? That's a super big advantage. And that is one of the reasons why we use version control, because it helps us be a lot more agile and aggressive, if you like. We're not feeling afraid all the time. You don't want to be feeling afraid if you're trying to be creative. If you're trying to be creative, which is what we're trying to do, if you're trying to be creative, you want to feel free, right? And feeling free means you're going to be feeling free to make mistakes. And feeling free to make mistakes works when you've got a version control system that acts like a time machine. All right. Now, a little demo of how this stuff works. This is a very, very short idea of how Git and GitLab work. The basic idea is on this screen here, I've got, hang on, I'll bring it up for everyone here on the stream. The basic idea is that you've got, in the cloud, you've got a repository. In this particular repository, I've got the lab repository, okay? It's living in the cloud, and it's got that little Van Gogh logo there because it's owned by Vincent. No, it's owned by the class, right? Owned by me, right? And so that repository is mine. You can't touch it, all right? It's mine. You can't change it. I don't want you guys messing my repository, right? But what you can do is you can take your own clone of that. You fork it. We call it a fork. You can fork that. That's the language that Git uses. You can fork it to make your own repository, which is all yours, okay? That one's all mine. When you fork it, it becomes all yours, all right? And that's what we see here, okay? So when I say mine, Vincent's. All right, so I've forked it. Now I've got my own personal copy of the thing, all right? I've got my own personal copy. This one here I can mess with. I can't mess with the other one because it's owned by the class. This one is owned by me, so I can go and modify it. Okay, then I can modify that directly in the cloud by going to the browser and editing stuff, okay? But I can also push and pull it to my own computer, and I can access it with IntelliJ or some other thing like that. And I can have multiple computers. I like computers. You can have multiple computers and have different versions on different computers. And Git will allow you to do that. The thing is, the authoritative copy always resides in the cloud in GitLab, okay? In GitLab. So you have to push your work up there. So if these two guys here are working, when one of them finishes their work on their laptop, they need to push it to GitLab, and then the other person can pull it and see it on their computer. Okay, in this example here, there's just one person working on it, and I've just got multiple devices, a desktop and a laptop, right? But if you're working as a team, similar things happen. And we learn about teamwork later on in, I think, lab 3 or 4, okay? And there's good integration into IntelliJ. You're going to do this in lab 1. All right. There is now time for a very quick break and also a mini quiz. So if you go to Piazza, what you'll see there is a mini quiz which you need to try and answer. Publish the poll. What's going on here? All right, quick break. If you want to stretch your legs, 5 minutes. There's a little problem with the poll here. Select the folder. Why is it doing that? Okay, if you're watching on the live stream, now's your chance to get a drink or something.
I think 5 minutes is not enough for fixing the issue, right?
No.
Let's just keep.
You just keep going, yeah. Yeah, it didn't happen before. I think it was the order in which I started things up. I tested it before.
When it shows the camera, but when you share the screen.
Yeah, it's just the screen resolution. I think it's due to me having PowerPoint open. PowerPoint messes with its idea of what screen resolution when you're doing whole hit. Yeah. Okay, folks, that was a very short break. I'm sorry that it's so short. We're running a little bit behind. So what we're going to do now is move on and continue with the J1 part of the course. So this is the second substantive part of the course. All right, what have I got here? What's that? Hey, I've got a question for you first, though. Can people tell me what your favorite programming language is? I want hands up. What's your favorite language? Yep. C#. Ha. Did you know that one of the designers of C# is an ANU alum? Don Syme. Look him up. Don Syme did his undergrad at ANU University medalist. Built, not C#, F#. F# is Don's, okay? But he helped write the generic system for C#. All right, another language. Anyone got another language? Yep, up the back there. What is it? R? Yep, great. Stats language. Any other favorite languages here? Yep. Haskell. Oh, yes, someone's done 1100. Anyone else? Yep. Python. Yeah, Python's almost ubiquitous, isn't it? Anything else? Yeah, it would be. It also will be a little bit sad. Java is a pretty unpleasant language. Although C# is as well. Any other languages? Okay, why have I got this thing here? Anyway, why have I got this giant spanner behind me? Because, rhetorical question. Because I love doing handyman stuff, work around the house and all that sort of stuff. And I like tools, really good tools, right? And that one there is a nice one. It's a spanner, it's a 10 millimeter, okay? And it's got a ring on one end and the open end at the other end. Great tool, very well made, really useful. 10 millimeter is really useful, right? A lot of stuff's 10 millimeter. Great spanner, okay? Is this my favorite tool? No, it is not my favorite tool. If you went to a mechanic and said, what's your favorite tool? They'd look at you like, what do you mean, what's my favorite tool, right? We don't have a favorite tool if we're a mechanic, right? We don't have, it's like, you know, it's just the wrong concept. It's also the wrong concept for programming languages. I know sometimes we do like our programming languages, and that's totally natural and normal, okay? We enjoy programming in a certain language. But my point is, this is the metaphor. A language, a programming language is merely a tool, okay? Whether it be Java, C#, Haskell, or whatever. Choose the language for the job you want. If you try using the spanner to fix the screw over here, it's not going to work very well, okay? Likewise, it's not going to work very well for certain problems to use Haskell, and other problems are not going to work very well with Python, or not going to work very well with Java, okay? So you need to understand enough about programming languages to know that there's no such thing as the best programming language, okay? That's just not how it works. And if you're interested in languages, let me tell you, there's a very cool conference that I was actually involved in it this year. It runs only once every 15 years. It's called HOPL, History of Programming Languages. And there's really great talks on the history of major programming languages, including C++ this year, and F#, and a whole lot of other cool languages. JavaScript, I think. Yeah. Anyway, you can go look that up. But I want to make this point. So please, some people cultivate a bit of a fanboy thing about languages. That's okay, but don't take it too seriously, folks, because a language is merely a tool. Why are we learning Java? It's, we want you to learn multiple paradigms. That's why the class that is often taken before this is 1100, and 1100 is Haskell-based, okay? So it's a Haskell-based language that comes before this. Java is an important example of object-oriented programming. Object-oriented programming is an important paradigm, very important paradigm. It's not the best paradigm necessarily, but it is an important one, and it certainly gets lots of use in industry. Java is very important for large-scale programming. So often you get these multi-million line projects, and often they're written in Java for a whole bunch of reasons. One of the reasons is that Java has a rich standard library. What does that mean? Well, that means that, like a library, you don't go and make up all these stories yourself. You borrow a story from a book, in a book from a library, right? You don't have to do everything from first principles. That's the idea. You don't write everything yourself. Instead of writing everything yourself from scratch, you get something that's written by someone else and polished and refined and tested and debugged and performance analyzed, and you use that thing, okay? Now, curiously enough, in this class, we're going to do exactly the opposite. I'm going to teach you how to build some stuff that you should actually use in a library. Why? So that you understand how that library works, okay? So we're going to do that a little bit in this class. But one of the things I am going to teach you is the power of libraries and the importance of libraries. And Java is a great example of a language with a powerful library. Imperative programming languages. Okay. Let me put imperative programming languages into context. We've got declarative languages. We've got pure functional languages, which are one of the declarative languages. And those of you who did 1100 will know Haskell is an example of a pure functional language. Imperative languages describe computation rather than, they describe it in terms of a series of statements that transform state. You do this, something changes. You do that, something changes. You do this, and something changes. Do it all again, and so forth. That's the imperative language style. Okay, and an object-oriented language inherits the idea of imperative programming languages and focuses on the idea of state and behavior being embodied in an object. Okay, so you might have an object. We're going to get to this very soon. An object which embodies state and behavior. And the behavior changes the state, okay? We're going to go through a lot of examples very soon. So, imperative programming languages, the three fundamental elements of an imperative programming language are sequence, selection, and iteration. What's sequence? That says, when I do this thing, the next thing I'll do will be the thing after it, then the thing after that, and the thing after that. Selection says, we'll do this thing, or we'll go and do that thing, okay? That's selection. And iteration says, let's do this thing repeatedly. And with those three key ideas, you can build up quite complex programs. Object-oriented programming languages are, one of the key ideas here is to help structure and encapsulate code. And we have code, which is behavior, which is tightly coupled with state, which is the data that gets manipulated by that code. Now, one of the things that's a great resource here is a Waterloo Java Visualizer. We're going to use that in this class. We're going to use it in a few minutes' time, actually. And it allows you to type simple Java programs, and you can watch their step-by-step execution, which is great because it's a great way to do to understand what's going on under the hood. The Oracle Java tutorials, if you step through those things there, they may help you quite a lot. There are links to all these under each of the modules on the course webpage. The Java standard library. Java has a very rich standard library, just like C# does. And there are things for doing things like I/O, which is input and output, graphics, so you can draw pictures, and standard data structures and many other things like that. The data structures like lists and stacks and things like this, which we're going to study in this class later. Learning and understanding the standard library is part of learning a major language like Java or C#. Right. Data types. The type of a unit of data determines the possible values that that data may take on. So the question is, we can have weak typing and strong typing. And weak typing is sort of like laissez-faire. You know, it's okay for this to have different types. So the idea of type, we're going to come to that more in a minute. But the idea is that different data types, like if you might want to think of a box and say, only this kind of thing can go in that box. Okay? And a strongly typed language says, you know, you can't do anything except put those things in this box. Whereas a more laissez-faire one says, oh, you can put whatever you want in the box. Right? And this is weak versus strong. Static versus dynamic says, we're going to tell you what shape these boxes are right at the beginning when I write that piece of code. Okay? Whereas dynamic says, let's do it later. Okay, we'll work that out later. And Haskell is an example of a strongly typed static language, and Java is a strongly typed language. It's mostly static, but does have some dynamic elements as well. All right, now we're going to do our next mini quiz. Let's see if I can make this thing work. Publish the poll. Hopefully you can see that. Oh man, Piazza is such a pain. There you go. Hopefully you can see that poll. And, yeah. All right, so now we're going to go and do this. What we're going to do here is we're going to do this using the Java Waterloo Visualizer. And to do that, we're going to go here and go here. And under each of these things, you see this little cup icon. That's the icon of the Java Waterloo Visualizer, and we're going to mess around with this example here. There you go. There's a little example. But what I'm going to do is I'm going to get rid of that, and we're going to type it all in ourselves. Okay. Now, I told you before that Java's a bit like a giant jet engine. It's all messy and ugly. This is a great example. All that gorp that you can see on the screen there is just stuff you have to do. It's just the price you have to pay for working in Java. Just a big pile of junk that you have to type. Luckily, when you use IntelliJ, you'll find out later when I go to using IntelliJ, you've got shortcuts that make all that stuff happen very quickly. Okay? But for now, you're stuck with the idea that you've got to type all this stuff in. See all that stuff up there? We're going to explain what all that stuff is soon. All right? But for now, I just want to show you, how this visualizer works and this notion of iteration. Okay? So not iteration, that's sequence. Okay, sequence, selection, iteration. So now we're just going to type some code in here. Notice that we've imported a library. This is a library called the scanner. The scanner is the way we read things in from the command line. Okay, the command line is, oops, hang on. Yeah, you can't use tab in this thing. All right, so we're going to type one here. We're going to say scanner. Whoop. Oh man, different keyboard. Gets me every year. What is, just seems like my fingers are in the wrong place. Scanner, in equals new, oh man, new scanner. And then what it's doing is it's creating a special kind of object which will read something in, and where we're going to read it from is a standard system.in, which means just input from the keyboard. Again, this seems all very mysterious. we're going to be explaining it more later, okay? So don't worry too much about this gobbledygook. Go up here, go back, and now what we're going to do is we're going to print something out. Luckily in IntelliJ there's shortcuts, which mean you don't have to type all this horrible stuff. That's another reason why we use IDEs with a language like Java. There's so much boilerplate, the IDE just writes lots of code for you. And as much as we like typing, which apparently I'm having troubles with today, having something type a lot for you is actually really helpful. System.out.println. Right, we type S out in IntelliJ, then press enter, and it fills in the rest for us. We're going to say, what are we going to say? We're going to say enter an integer. Enter an integer A, right? So this will get printed out when we run this. Let's just run this, visualize the execution. Now, I'm going to step through this thing, and it's created an object, which is the scanner instance. And that's the end of it. Didn't do anything. It was very, well, hang on. Oh, it printed it out to here. You can see that's the program output. It's right there. Okay? Now let's go back. And we're going to go and edit some more. We're going to write a few more lines of code here. Now what we're going to do is we're going to declare a variable of type integer. This is going to be explained to you in more detail later. There's going to be lots of stuff in this course where I reiterate things, okay? So some of this you're just going to have to take, it's going to be an article of faith for a few moments. Now we're declaring a variable A of type integer, and where we're going to get it from is from the in. We're going to get it from the scanner, and the way we're going to do that is say, give me the next integer that you input, next int, okay? And so what that says is, whatever the input is, which is the keyboard, get the next integer that gets typed into the keyboard and put it in the variable A. And then what we're going to do is we're going to ask them to enter a string B. Now notice that this is an integer, this is a string. Those are exactly what we call types. A string is, an integer is a type, and a string is a type. Okay, and then we say string, so we're declaring a type, and a variable which we can call B. We'll call it B. And the stuff in the quotes there, which is rendered in a browny red color, that stuff there is just the things we want to output. So it's really for the information of the human. It's not part of the program other than a piece of text that's going to get printed out. So now what we're going to do is we're going to say B equals in.next. This is a peculiar piece of Java that we don't have to say next string. We just say next. And next is implicitly going to give us a string, whereas next int gives us an int. All right, that's another odd thing, which you're just going to learn after a while. And then what we're going to do now is we're going to print all this stuff out. System.out.println, and print line means finish the line off at the end, right? If I didn't put the ln at the end, it would just print it out, and then the next thing would get printed right next to it. If I put the ln, it does the enter at the end, if you like. Okay, so then we say A, and then we do this strange thing here, where we say that's a string that's going to get printed out, and then I can do a plus sign, and it will actually print out what the value of A is, and then we can say comma B, and at a plus sign it will do whatever the value of B is. Okay, so B is a string, A is an int, and we can type in whatever input we want. The way the Java Waterloo visualizer works, you can type the input here, so we're going to type the input in, we can make up whatever number we want. Right, so this is just a string. It's not actually a number. It's just a string, right? And that there is 2 characters which make an integer 13. So now let's visualize the execution, and we step through this thing. We create a thing which reads stuff in from the keyboard, and we print it out down here. We say enter an integer, and then we say enter a string. And notice we entered this integer in. And where is A? A has taken on the value of 13. See that? Now what we're going to do is enter a string B, and now there's a value here B which has the value of 20. Okay, and then we've printed it out, and that's what we see down here. Okay, so that was a very simple piece of imperative programming. There's no loops in here, so there's no iteration, and there's no branches in here. There's no if statements, so there's no selection. All this is sequence. one thing after the other. And over here, we're seeing some of it get visualized. I'm going to do much more interesting examples later. Some of you are thinking, man, how are we going to survive a semester of this? Don't worry. There's going to be plenty of challenging things for all of you to do. There'll be stuff in this course that will challenge every person in this class, I can promise you. Okay? We're going to move faster and faster as we get through this. So for those of you who are thinking this seems very basic, don't worry. There's a lot more to happen. Now let's move on to J2. Here it is. And all right, what we're going to talk about in J2 is about types. I mentioned types really briefly and just glossed over a few moments ago. I talked about an int and a string. They were the two types that I mentioned. And we're going to talk about objects, and we're going to talk about classes, and we're going to talk about inheritance in interfaces. These are some of the biggest concepts in Java. But we're not going to cover it once and for all right now. We're going to do this again and again and again in more and more detail and more and more depth through the semester. This is your first introduction to these concepts. Okay? So, what is an object? Please remember this. This is a really important idea. An object combines state and behavior. Objects combine state and behavior. They have fields, which is the state, and they have behavior, which is manifest as methods. Behavior is something that changes the state. The field is data that lives in the object. Okay? And so you can change the state by using a method. So for an example, if you have a bicycle, the state might be the current speed. Okay? So you ask that bicycle object, what is your current speed? That is data that lives in the bicycle object. The direction and the cadence and what gear you're in, they're all things which are state, which describe that bicycle. Okay? Behavior is something I might say, go faster, change the cadence, change the gear, turn the handlebars that way, turn the handlebars that way. That's behavior. It's like verbs and nouns, okay? But state is telling you what the actual value of the thing is inside the object, and behavior is changing that or reporting it, okay? Now classes, okay, I've got Aristotle here. What is this all about? Can anyone see the link here? This seems very strange. But what Aristotle was on about here was classification, the same base word, same root word. Classes, classification. We're classifying things into groups. Here, this interesting notion of animals, blood-bearing animals. You had four-footed animals, you had birds and egg-laying and so forth and so on. That was the way he divided the animal world up back in the day. All right, we've got very much more interesting ones now. One thing you'll notice is if you know anything about genetics or biology, that we have a tree-based thing. This thing is related to that thing, which is a subspecies of that thing and so forth. And you can see these really lovely taxonomies. They're about classification, classifying things. Root word class, okay? Class. Okay, we're going to do this a lot in this class, different English word. So, a class in Java is a blueprint, or a type, if you like, for an object. So, an instance is one instantiation of that type, okay? And we call it an object. Object and instance are synonyms in Java. When I say that object, I might say that instance. Synonyms, okay? A class is the blueprint or definition for many instances, okay? So, for example, the instance of the bicycle is the one that you own, or the one that you own, or the one that you're riding home, or whatever. That's a very specific one, okay? The class might be the particular brand of bike that you have, and that particular model of that particular brand. Okay? And it might be a rich structure that says, oh, you've got a two-wheel bicycle, it's made by this manufacturer, it's a road bike, and it's got blah, 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 and that describes it. Okay? It's a subcategory of a subcategory of a subcategory. And two people in this class might have the exact same bike, but they're different instances. Okay? How are you going to tell them apart? Well, apart from the paint color, maybe they probably have serial numbers stamped into the frames. Okay? And they will definitively identify these as different. They're not the same thing. It's not an illusion. They're concretely different things. Okay? So the class is an idea, the idea of this design of bicycle. The object is a concrete thing. That is your bicycle and your bicycle. Okay? And they're different. Okay? So we can make many, many instances of the same class. They'll all look the same, which is the whole point. Okay? But your bike might be going a lot faster than your bike. They'll have different state. Okay, your bike might be here, your bike might be there. They have different state. okay? But they're of the same class. They look just the same because they're made by the same manufacturer and they have the same size or whatever, okay? So inheritance is this idea that you can understand if you understand biology. So here's an example here. So a subclass extends a superclass. So you've got a very particular thing at the top there, which is this particular model of bike. And it's got a very particular type. It's a cyclocross bike. It's in the subclass of upright bike, which is part of the class of bikes. And in Java, in English, if we don't know how to classify something, what do we call it? What's the English idiom that we use when we don't have a way of saying it? Like we don't know if it's an apple or an orange or whatever. Yeah, exactly. We use the word thing, right? That's an idiom. In English, we say thing. Okay? I have a thing. It's not very helpful to say that because I haven't already described it, right? Okay? Java has the same concept and it's called Java lang object. Object is the most universal, most general, most non-specific way of describing a thing. Okay? So we try to avoid it because it's really unhelpful just to say it's a thing. It's much more useful to say it's an apple or it's an orange or it's a car or an elephant, right? That's a very concrete thing, right? Whereas if I just say it's a thing, then you don't know very much about it, right? So that's the idea. And Java lang object is at the root of that family tree. Like if you look at a genetic one, at the top it'll be, what, animal, I guess? It'll be right at the root of the tree. And you'll have these more and more specific things at the leaves of the tree, right? A very specific species of a snake down here somewhere, and a reptile here somewhere, and animal right at the top. Well, in Java, it's Java lang object, okay? Key idea. Java has this concept of interfaces. Interfaces are a curious idea. A lot of people trip up over them. They're actually not so hard to understand if you frame it the right way or think about it the right way. Java has this concept of interfaces. An interface is like a promise or a trait. It means that you can do a certain kind of a thing, right? It can do a certain kind of an activity. I used the wrong word there. You can do a certain kind of activity. And that kind of activity could be shared amongst things that are very different. I'll give you an example. You might have the ability to carry passengers, right? Transport, right? But that property of moving someone, right? Or of being a vehicle could be shared by a horse, which is legitimately a thing for moving people, or a motorbike, or a jet plane, right? They are in some way completely unrelated ideas. Fighter plane, bicycle, elephant, or a horse, right? They seem really unrelated, but they all share what we in Java we call an interface, or in English we might call it a trait, that they all have the capacity to move a person from one place to another. And maybe take directions. You can say, go this way, go that way. You can make the elephant go this way, make the elephant go that way. You can make the airplane go this way or that way. You can make the bike go this way and that way. They all share that property. Yep.
So why would that be an interface and not a superclass?
Because a superclass in Java is a concept where you can only have one parent. And that is the heart. It's a great question here. Great question. Why did we talk about those things as not being part of the inheritance hierarchy, okay? This is a cross-cutting idea. So we look at our, the taxonomy in biology, right? And we can say this thing's related to this thing and its grandparent is the, is the mammal or whatever it might be in the family tree. But that's a totally different concept to the idea that it's a form of transport, which the horse has, but the lizard's not a form of transport, right? Or even a dog is hardly a form of transport. But so that concept of having that trait is something which transcends or cuts across this other hierarchy that you have. Okay? And in Java, its notion of inheritance is strictly single inheritance. Each class can only inherit from one. So it's always a tree. It's not a big complicated graph. Other languages have what's called multiple inheritance, which is another way to achieve this. Okay? But in Java we don't, and we have interfaces to say, it's basically a contract saying, yeah, I'm a form of transport, I have the following interfaces. You can tell me which direction to go, you can tell me to go faster, you can tell me to go slower. And the horse has all those things. You tell the horse to go that way, you tell the horse to turn left, to turn right, to go faster and stop. Horse has all those things, so does the car, so does the airplane, right? So it's a contract. And so any object which implements that contract shares in Java what we call that interface, okay? And now time for a mini quiz. Another one. Okay, so there's a mini quiz there for you. And here, this is what I want to show you before. This here, anyone know what this thing is? Yep. Yeah, a jacket loom, right? It's a loom. It's for weaving. Yep. Yeah, sure. Question about the previous stuff? Yep. No. In English language, the idea of an interface is an abstraction, but Java has the word abstract is a very important word in Java, which we're going to talk about later, which is different to interfaces, so let's not confuse them. So that's an unfortunate choice of words as it happens. But interface, think of an interface more as a contract that says, I will offer you methods. When I implement my class, it will have methods for stopping, for starting, for going straight ahead, for turning left and turning right. And anything that has that, we're going to call it transport, for argument's sake, okay? That's a contract, right? And we're not talking about abstract classes yet. We'll talk about that later, okay? But that's what an interface is. Think of it more as a contract. So the horse might implement that contract, the airplane may implement that contract, and the car may implement that contract. And then you can talk to any of those things and ask all of them to go forward, to stop, to turn left, to turn right, and so forth. Right? Because they all promise you, the class promises you that it will implement that contract. Because it says this class, horse, implements movable thing. Right? This is a jacquard loom. Okay, this is a jacquard loom. The jacquard loom is a very cool thing. It dates back a very long time. And if you can see the thing on the left there, the thing on the left in this picture is actually a program. Right? It's actually a program. So see how it's got all these bits of like cardboard all strung together with a piece of ribbon? Okay, if you look really carefully, those bits of cardboard there, they all have, on the left there, all those bits of cardboard have holes in them, and those holes control the way the loom moves. And so that beautiful carpet there on the right is designed by a designer but implemented as what's basically a program in those punch cards. And as those punch cards move through in the machine, it changes the pattern and you get this beautiful carpet coming out. That's actually a really old technology. It's very similar to one of the key ideas we're talking about now, which is sequence, okay? So we do this, then we do this, then we do this, then we do this, and you produce a beautiful carpet, okay? And if you do it repetitiously, like maybe you got the same recurring pattern, that would be iteration, okay? Sequence, selection, iteration. There's no selection here because it's always doing the same stuff, but there might be repetition, which would be what we call iteration. All right, J3, Introductory Java 3, naming literals and primitives. So what is a Java module? A module is a named group of packages and related resources. So it allows you to encapsulate things and say what their dependencies are, okay? We are not going to discuss this in great detail in our course, but it is part of Java. And so there it is on the table, but it's part of the framework around which we talk about encapsulation. Why do we want encapsulation? Does anyone know what encapsulation means in English? Just in normal English? Yep. Beg your pardon? Yeah, to put something in a capsule. It means, and what does that do? It means it hides away the detail. Okay? It would be pretty bad if when you went to get on a plane, you needed to know how that jet engine worked, right? That would be bad because you probably wouldn't know how it worked, right? Okay, likewise, it'd even be bad if the pilot had to work out how the jet engine worked to be able to fly the plane. We don't want that to happen. What we want to do is say, here's a jet engine, it behaves in the following way. You don't need to understand every part of that jet engine to be able to use it, to be able to fly the plane. So the pilots, they don't need to understand the insides of the way that jet engine works in order to fly the plane. They'll have some principles, they understand the broad ideas, but they won't understand all the detail. No way, that's the job of a mechanic, an airplane mechanic, right? Or an engineer. But it's not the job of a pilot to understand every bit of that really, really complicated jet engine. Okay? And that's because we encapsulate. In fact, normally you see a cover over the engine, which is encapsulated in a cover, which hides all that gory detail, both literally and metaphorically, right? So hiding the detail. That's what encapsulation is about. And it's one of the most important things in programming. That is, if you guys are working together in an assignment and she writes this thing over here and you want to use it, you don't want to know exactly how she did it. You want to be able to use it without having to understand every single thing she wrote, right? And if what she did is well encapsulated, you can do that, okay? Because she writes it in a way that says, my thing will draw this picture up on the screen, and we'll do whatever you pass as an argument will get printed on the screen, right? Now, how she actually achieved all that, it doesn't matter to you. All you want to do is to make sure that the thing that she says is going to do this thing actually does it. And if it does, that's great. You don't need to dive into the details of how it works. And when you've got software that has 100 lines of code, this is a little bit important. But if you have software like the thing I was working on in Munich, which has over 1 million lines of code, maybe upwards towards 10 million lines of code, there's no way in the world you can understand all of it. No one can. It's beyond human comprehension to understand that amount of complexity. We need to encapsulate. Okay, so this is one of the key ideas in encapsulation, and a module is one of them. We don't study modules in detail in this course, but we do look at encapsulation a lot in this course. Okay, packages. What is a package? A package is what we call a namespace. So that person up there is Mary. Okay, there are lots of Marys in the world. Okay, there could even be Mary in this class, who knows? But that one we know is Mary, Queen of Scots, because we recognize the picture as a historical figure, okay? The thing is that by saying Mary, Queen of Scots, we've immediately differentiated her from any of the other millions of Marys in the world, okay? Or maybe hundreds of thousands of Marys in the world. We've differentiated them by placing them in time and place with that qualifier, Mary, Queen of Scots, not just any old Mary, okay? So there's this idea that two people can share something and yet can be differentiable. You can differentiate them and not have a name clash. I remember once when I was a PhD student, I was in this small lab, we were learning from this masterclass, and the person who was actually visiting from the States, he said, he got us to go around and introduce ourselves. I put up my hand and I say, my name's Steve Blackburn, blah, blah, blah. The person next to me, he says, my name is William Johnson or something. And the person across from him just like almost erupted in rage and said, no, my name's William Johnson, just by chance. There were two people with the same first name, last name in the same room. And for whatever reason, the person who had that happen just reacted in a really strange way to this idea of someone stealing his name. Weird story, but true. So we have this notion of a name and a namespace, but we normally get that differentiated. And back in the olden days, in different languages and different cultures have different ways of doing this, right? They have John the blacksmith, right? Or whatever, and then that becomes John Smith, right, in modern English, right? So, but originally it was which John? Oh, the one who's the blacksmith. That's the one we're talking about, or John the baker, or whatever, or Mary the seamstress, or whatever it might be. Okay, and that's how we differentiate one thing which has a given name from another. Packages allow us to do that, which means that we can have two things with the same name. We can have two Marys, but they're differentiated because we've said this is the Mary that lives in that package. This is a different Mary that lives in that package. Okay, and Java allows us to do that. It's a namespace. Java variables, we have instances, right? An instance of a variable is a thing that lives inside of an object. In the case of the bicycle example I gave you, the thing that lives inside of the bicycle could be like what gear you are in right now. That could be an instance variable. Okay? A class variable is a property of all bicycles of that type. So what's an example? Okay, let's think of another example of an instance variable for a bicycle in my crazy example, my running example of this bicycle thing, okay? What was that? Yeah, maybe the PSI of the tires, say, some other data point that tells you something specific about that particular bike, and two of you may have the same type of bike, but you have different tire pressure at the moment, right? Something like that, for example. What would be some data associated with the type? Okay, you both have the same type of bike. What's a piece of data that's associated with the type? What's an example? And that in Java is what we call a class variable. Can anyone think of an example? Yep. Yeah, exactly, right? So the size of the wheel. This particular type of bike has a 700 wheel, right? And both of your bikes, if it's the same type, will have exactly the same size wheel, right? It's a property of the type, not of your instance or your instance. okay? Unless you start modifying your bike, but then it's no longer that type, right? So it's a property of the type, and we call that a class variable. So in our crazy analogy here, our crazy running example, the size of the wheel is a class variable. The tire pressure or the speed of the bike is an instance variable. The instance variable is associated with his bike and his bike. The class variable is associated with the type of bike we're talking about. It has a certain size of wheel. All right? Local variable. A local variable is one we use when we're computing things just at the moment, right? So we'll come to that more later. We put them on a thing called the stack, and we see that in the Waterloo visualizer. We see that later. Parameters, these are things that we use to pass arguments to other functions. Okay, we have this concept of functions, which is coming up soon. I haven't explained it all yet. So you're thinking, wow, there's so much stuff here he hasn't explained, or he's not explaining it real well. There's a whole bunch of stuff which we're going to explain more soon. Okay, and a parameter is another type of variable. It's one that we pass as an argument to a function. Okay, so when I say turn, the argument or change speed, the argument might be what speed I want you to do. Okay, so that might be, we call that a parameter. Okay. And all right, naming. In Java, names are case sensitive. We have case sensitivity in names in Java, okay? Case sensitivity, so upper and lower case matter. In Java, some languages, case doesn't matter. In Fortran, I think, yeah, in Fortran, everything's uppercase. Okay, in Java, you can have upper and lower case in your name, and it matters. If you use upper and lower case and then have the same word with a different casing, they're different variables, okay? White space isn't permitted in the name. You shouldn't, but you can put underscores and dollar signs in names. Java keywords and reserve words cannot be used. Can anyone think of a Java keyword or reserve word that you've just bumped into in the last half hour of lecture? Yep. System, yeah. Actually, that's not a keyword, actually. System is actually the name of a package, okay? But, I still didn't hear. Puppet. Public. Yeah, public is absolutely a keyword. So is int. That's the name of a type. Okay? You can't use that as a variable name because they've got special meaning. We're going to learn these as we go along. Okay, so there's a whole lot of special words. Luckily, when you type stuff in your IDE, they actually come up in different colors. It helps you understand that these are these special words because they get colored differently in the IDE. It'll be very obvious once you start typing. Capitalization conventions. Normally, we use a capital letter at the start of a type. So if I say bike, I use a capital B, and the rest is lowercase. It's a convention. Okay? Variable names always start with lowercase, and if it's a multi-word variable name, which is a good idea if it's a complicated idea, then you use what we call camel case. So you use uppercase to start each new word. All right? And constant names use all caps and underscores, like max gear ratio there as a constant. We've got all these different data types in Java, which are what we call primitive, and we're going to explain more the difference between a primitive data type and an object, because one of the weird things about Java, Java's object-oriented, but oddly enough, it's a very pragmatic language, and not everything is an object. Really annoying. Other languages are pure object-oriented, and everything's an object. Does anyone know of a pure object-oriented language? Like Smalltalk's one, for example. Okay, everything's an object. In Java, that's not true. And the reason why, which we're going to come to later, is objects live in boxes and boxes are expensive. That's a very short version of the story. I can explain it in a lot more detail later. And so what we do with some things is we don't put them in boxes. And this is the list of what are called primitive types in Java, which makes teaching Java annoying, it makes learning Java annoying, but it makes Java go a little bit faster. So that's why they put it in. All right, just to annoy you, but they get to go a bit faster. So we've got these primitive types here. There's 8. I know that off by heart. There's a byte. Then there's these different types of integers. There's a byte integer, there's a short integer, there's an int, which is a 32-bit integer, and a long. So 4 of these things are different sizes of integers, okay? Different numbers of bits. Different numbers of bits means you can express bigger and bigger numbers, okay? If you've only got 8 bits, you can only do 256 numbers, okay? So 256 different numbers, and the way they're spread is we go from minus 128 to plus 127. Then we've got 2 different types of floating point numbers, which are a little bit like a real, I suppose, but they're fixed number of bits. Okay, what we call a float, which is a 32-bit floating point number, and what we call a double in Java, which is a 64-bit floating point number. And that's when you want to represent a fractional number, okay? A fractional number rather than an integer. And we've got Booleans, which have yes or no values. And we've got what we call a char. A char in some languages is 8 bits and can only represent what we call ASCII. In Java, it's a 16-bit Unicode character, which means we can represent lots of different characters, okay, which is kind of nice. All right. Literals. A literal is when you type in an actual value in your code, which you do when you, like in an example where you say, you know, A equals 1. 1 is a literal. You say it's actually equal to the value 1, right? When you do this, the compiler knows exactly what it means, and there are some special cases. If the compiler is not sure if that 1 is a long 1, or a short 1, or just a regular integer 1, then if you want to be very specific about it, you can use the capital L to indicate this one I'm talking about. I want you to think of that as a long. That is, I want you to think of it as having 64 bits, even though I haven't really otherwise told you. So you put that L there, and that prefix tells you. The OX says, I'm going to write this number, but I'm going to write it in hexadecimal because I find that fun, right? So you go OX30, which means is decimal 48, but written in hexadecimal. And you can also do the same with binary. OB means binary, and you can write a binary number, which is 48 in binary. And F is to when you say you want to make this thing a float, so please read this number 1 as a float, which means 1.00, or read this as a double, okay, which is the same idea but with more precision. You're allowed to use underscores. Underscores are kind of thrown away when you write a literal number. They get ignored by Java, which is kind of handy if you want to make things easy to read. So in a credit card number, you can do it like that. All right, now we've got a mini quiz, and we might just do a tiny bit of coding, and then we're going to finish up. Last mini quiz here. Okay, there's the mini quiz and some coding. We're now going to go to some code, and I'm going to write up here. We're going to start writing our first code. We're going to be doing this most of the time in file, new, Java, package. Where is it? Package, and J02. Like that, and then we can say a file new, new Java class here, and we're going to call this thing basic imperative. Now hang on, whoa, what did we just do? We just did, I'm confused, we just did 3. We're going to do strings first, okay? We're going to call this strings. Okay, and we're going to change this. This is one thing you can do here. You say change, hang on. Keep pressing the wrong key here on this keyboard. Here, change, refactor, rename. Rename, we're going to change this thing to be J03 because I'm actually writing stuff for J3. Okay, now, and it's all kind of big and goofy because of that issue I had with the screen resolution earlier, which we'll fix up later. Okay, so what we're going to do now is the IntelliJ has already written all this junk. Notice how it's got this package thing at the top? That's because I put it in a package called J03. As I write code, I'm going to put it in a package name that reflects the lecture module that I'm talking about. And I'll fill in some stuff that I've missed here for J01 and J02, which I did in the Waterloo visualizer, and we'll look at those in a short while. And strings. So what we're going to do now is we're going to write a main method. Remember when we looked at it in the Waterloo visualizer, there was all that other gorp. Hang on, I'm just feeling bad here. I feel like I've skipped J2. No. Yeah, I did skip over some stuff. Man, I'm going to have to go back. All right, so I'm just going to do this, and then I'm going to go back because I skipped over some stuff I wanted to do earlier. Okay, so this is J03. Where are we? Make sure I'm... Yep, all right. Now, there's a little bit of magic you can do in IntelliJ. See, I just typed PSVM, which is a shorthand way of writing all that stuff up there. And that's the way you start writing a program in IntelliJ. You can see it's a lot easier than when I did it in Waterloo Visualizer where everything was very, very slow. So I'll say string x equals hello, keyboard, hello, right? And then I can say, I can print that out. And again, I can do a shortcut there, S out, and then it will print it out. And I can just print out X, okay? Now I can run this program by going like this. I can say, control, run. And it's compiling, it's doing work down here. You can see it down there where it's doing some work. I forgot to put this side by side. It's doing some work down here. It's a bit slow. There's live streaming. It's doing lots of stuff. It's working really hard. Patience. And there we go. It ran and it printed out hello. Hooray, our first program. Now what we're going to do is we're going to write something more here. We're going to say string, oh man, y equals world, and then we're going to print out y. So system, s out is the shortcut, like that, and we can say y. And now what we should find is that when I go up here and hit that run button, I don't need to go and once it's done it once, I can just hit this little green button there and it'll run it again. And it should compile it. So it's building down here. You see that? It's a little bit slow because I'm doing all this other stuff on my laptop at the moment. And there we go. We got hello and world. All right. Now the last thing we're going to do here is we're going to say this out x plus space plus y plus exclamation mark. And what that's going to do is more Java magic. It's going to do a print out. It's going to take x, which is hello. It's going to take, it's going to print out a space. Then it's going to do y, which is world. And then it's going to add to that another string, which is the exclamation mark. So here, that plus sign means stick together these strings. So we've got x, which is a variable of type string. What this space here, which is a literal string. This y here, which is a string here, which we declared to be world, and then we've got another literal here, which is an exclamation mark. If we run this, we get hello world. Now, once that's done, I'm going to quickly go back and do the visualizer that I forgot to do earlier. Waterloo visualizer. Go back to our lectures. Oops. And go to J2. And then we're going to finish off with our bio. Every class, I'll do this. Every class, I do a biography at the end, which we're going to do in a few moments. But let me go through this thing here, which I skipped over by accident. This is really simple. I just want to step through the idea of one thing happening after another, which is an essential part of the previous part of the lecture, which was bad of me to forget. All right, so we go like this. First of all, we're going to declare a variable I, and we're going to set it to some value, like that. And then we're going to print it out. We're going to say system.out, oh man, keyboard, out.println, like that, and print out I, okay? And that should print out 0. If we visualize this, oops, I didn't mean to save it, visualize it, what we're going to see is a new variable on the stack, what we call the stack. We're going to learn more about this later. We're going to see this little click. There we go. So there's I, and it's 0. And then we're going to execute this thing, which will print out the value of y, which should print out a 0 down here. Let's look. There it is there. Okay? So now let's go back to edit the code. And then I'm going to do something very simple here. I'm going to have a statement which is going to change. This is imperative programming. It's going to change the value of I. How am I going to change it? I'm going to use a plus sign. And we all know what a plus sign does to integers. It's addition. It's what we call addition in mathematics, right? So we can say I equals I plus 3 or something, or 7, whatever, some prime number. Like that, it doesn't matter, it could be anything. And then we print it out again. And so now what should happen is that value that was I, which was 0, is now equal to 0 plus 7. So now I should be 7, and we'll print out 7. Visualize the execution. And here we go. And we see I is 0. And 0 got printed out. Now I is 7 because it's 1 plus 7. And now 7 should get printed out. Okay, let's go back and edit the code. And now, if I do the following, I equals 256, and then I print it out, what's going to happen is the value of I should be changed to 256. We visualize that. That's the video. I don't know, something strange happened to the video there. That's unpleasant. I don't know what it's done to our live stream. All right, so now I is 0, then I is 7. Now we print that out, so that's printed out. Now what's happening is I'm making I the literal value 256. So now I is changed to 256. I is a local variable, it's sitting in this frame. And then we print that out. And the last thing we're going to do is do something very, very simple and silly. We're going to do the following. I equals I percent 10. Does anyone know what percent is in Java? Anyone want to guess? Modulo. Anyone else got another idea? Quick. Does everyone in the class think it's modulo, or do people not know? Put up your hand if you think it's modulo. Put up your hand if you don't know. That's okay, it's cool. It's not modulo. It's integer remainder. It's integer remainder, and people get them confused, and they're absolutely different. Modulo and integer remainder are not the same thing. So what percent size says is divide it by that number, in this case 10, and whatever is left over, the remainder, is the value, which for positive numbers is the same as modulo, but for negative numbers it's not, right? It's integer remainder, okay? So I'm being pedantic, but programs, as you will learn as you do your lab, computers are incredibly pedantic. If you're writing software that controls the autopilot for a plane, let me tell you, computers are pedantic. You get that wrong, you crash the plane, lots of people die. Okay, we don't want that. So this is something you're going to learn in this class. We do lots and lots of tests. The computers are testing your software all the time. If you make a small mistake, it'll yell at you. Okay, well that's the intention. Okay, it's fussy. All right, so we visualize this, and then what we get is the value here is 0. Then we print that out. Then the value becomes 7, and then we print that out, and it's gone off the screen because the video got reset. And then we set the value to 256, and we print that out down the screen here. And then finally, we divide by 10 and take the remainder, which is equal to 6, which of course is modulus 10 because it's a positive integer. And then we print that out, and we're done. All right, finally, it's right on time to finish. Let me quickly do our bio. And there's some other parts for J2, which I'm going to do in Friday's lecture. But the bio for today is Alan Turing. Who's heard of Alan Turing? All right, you all need to know who Alan Turing is by the time you finish this class. He's one of the titans of computer science. In computer science, we don't have a Nobel Prize, but we do have the Turing Award, okay? The equivalent of the Nobel Prize in computer science is named after this guy, Alan Turing. An incredible person, laid the foundation to a number of different things in computer science, famous for a number of things, including his insights about artificial intelligence, his insights about computability, what you can compute and what you can't compute, and his work with cryptography in breaking codes in World War II that a lot of people say accelerated the end of the war, helped the war end earlier because of the work that he and his team did. He was also a homosexual and sadly died early because of his persecution by the British government, and they took like 50 years to apologize for that. So he's one of the greats of computer science, a really interesting character. I highly recommend you read about him and learn more about Alan Turing, one of the greats in our field. All right, thank you very much for showing up, whether you're on the live stream or you came here in person. It's so good to see you all again, and I'll see you on Friday.